Hello, welcome to section 4.4 of chapter 4, Compounds and Their Bonds. We're going to be looking at the polyatomic ions in this chapter. Poly means many and atomic means atoms. So this is where we have some ions that are multiple types of elements that are together, okay? Like the sulfate and the nitrate and the ammonium ions. So polyatomic ions are groups of atoms with an overall charge. That is, they travel together and they keep a charge to them. Usually a non-metal such as phosphorus, sulfur, carbon, nitrogen, or oxygen, they will usually have either a -1, -2, or -3 charge. There's really only one positive ion, polyatomic ion. So common, these end in ATE, sulfate, which is SO4 2-, phosphate, which is PO4 3-, and nitrate, which is NO3-. Now there's no rhyme or reason to these. I have really tried to think of cool, fun ways to memorize them. There's really not. Luckily, you'll be able to look at some of your materials and have a list of those. When the ion that's related to sulfate has one less oxygen, instead of ending in ate, it ends in ite. So sulfate with SO4, SO3 is sulfite. Notice they'll have the same charge. PO4 3-, phosphate, PO3 3-, phosphite. NO3- nitrate, NO2- nitrite. Now, the exceptional ones are CN-, which is cyanide, OH-, which is hydroxide, and then the positively charged one, this is the only one we're going to see, is the ammonium. Okay, so that's the only one that would be the first name of an ionic compound. If you add a hydrogen, it reduces the overall negative charge, so you have a carbonate, CO3 2-. If you add an H to that, it becomes HCO3-, and instead of carbonate, we now call it bicarbonate, or sometimes hydrogen carbonate. With a sulfate, SO4 2-, if you add an H plus to that, you get bisulfate from sulfate. Okay, and so that's how that rule goes. The halogens, the chlorines, bromines, iodine, fluorine, form 4 polyatomic ions with oxygen. All of them have a -1 charge. So you can have perchlorate, which has got 4, chlorate, which has 3, chlorite, which has 2, and then hypochlorite, which has only 1 oxygen. But remember, they're all a -1 charge. So when we write formulas that have the polyatomics, we use the same rules that we were doing before in balancing. We just use the polyatomic part for that charge. So like if we're putting magnesium and nitrate together, magnesium has a +2 charge, nitrate has a -1 charge. So it's going to take 2 nitrates to neutralize the charge of the magnesium because it's a +2. And so what we do is we put the NO3 in parentheses to say there's 2 of those. Because if you didn't and you wrote magnesium, get my pen, magnesium, nitrate, and 2 of them, it would look like we had 32 oxygens. So that's why you put that in there. So let me write that a little bit better. So instead of writing MgNO3 2, by putting that in parentheses, that tells you that you've got 2 NO3s. Okay, the magnesium was a +2, the nitrate was a -1, so that's why we had 2 of those. So let's look at these and see if we can figure out aluminum. Aluminum is a +3, if you recall. Nitrate is a -1. You'll get used to these after a while, but I mean, like I said, you just basically have to memorize them or look them up. All right, and so since that's a +3 and that's a -1, you look at it as a whole. So you have Al NO3. How many of those would you have to have? 3. Okay? So our answer would be that one, right? Copper 2 nitrate, that tells us that copper is what? A +2. Nitrate is a -1. So we need how many nitrates to equalize that charge? 2. So we'll have CuNO3, 2. Iron, the Roman numeral tells us it's a +3. The hydroxide, if you look back at that, it's an OH -1. And so in order for those to neutralize each other's charge, you're going to have 3 of those, because a -1 times 3 is a -3. And we already have a +3 on the iron, so we have to neutralize each other. All right, and finally 10. Remember 10 is SN. SN, it's telling us is a +4. I like it when it tells us. OH- is a -1, so it's going to be SnOH4. Yes? Let's see how we did. Yay. Okay. All right. So the guide to naming ionic compounds with these guys, we're going to identify the cation and the polyatomic ion. We're going to name the cation using the Roman numeral, if it's necessary. Then we're going to name the polyatomic ion, and whether it ends in 8 or ite or whatever, and then write the name of the compound with the cation first and the polyatomic ion second. And so with calcium nitrate, you have the calcium and the NO3, calcium nitrate. Fe is iron, PO4. On this one we had to figure out what the charge was, and we used the anion. Even though it's a polyatomic, I have to look it up. It's a -3, okay? And so that -3 tells me the charge on the iron, so that I can write the iron 3 phosphate. All right, so if you want to stop me for a minute and see if you can do these, and then come back. All right, so I'm just going to tell you what these are. The Mg is, we know, is what? Magnesium. And the SO3 is what? Sulfite. If it was SO4, it would be 8. So SO3 is ite. It's just that rule, and these just follow the rules, okay? So this one is magnesium sulfate. This one is calcium, all right, ClO3. And that one, if you recall, there's 4 different ones. This one is the chlorate, as opposed to hypochlorate, perchlorate, chlorate, and then whatever the other one is. Okay? Let's see how we did. And we did pretty good. Okay. All right. So let's name these. Now, these have the transition metals. So when we name these this time from the formula, we're going to have to tell it what the charge is. You can't always go by this number. You've got to figure out what the charge balance is before you name it. Now, we know it's going to be iron something sulfate, right? All right, so the sulfate, if you remember, it's a -2, and we have 3 of those, so that gives me a -6. I've got 2 irons, so 6 divided by 2 is 3. All right, so that tells me it's iron 3 sulfate. But it's got a 2 there, so you'd be tempted to say it was 2, but you have to look at that overall charge balance in order to see which one it is. Barium phosphate, so barium phosphate. Okay. Nope, it's not phosphate, is it? PO4 would be phosphate, so I missed that. It's phosphite. All right, so barium phosphite, we know that phosphite has a -3 charge, and so times 2 is -6, and so 6 divided by 3 is 2 to tell me the barium, so it's barium 2 phosphite. Lead, I know PB is weird, lead, and this polyatomic is what? Carbonate. And if you remember, carbonate has a -2 charge. You just have to look at the table. There's no way you're going to remember all these right off the bat. So that gives us a what? -6. We only have one of the leads, so 6 divided by 1 is 6. So this is actually lead 6 carbonate. That one's pretty weird. All right. Now this says it's lead 2 carbonate. Where did we mess up? You know what I did? I did something that's a common mistake. I'm kind of glad I did it so I can point this out to you. What I did was I looked at the oxygen, didn't I? Instead of looking at the polyatomic. The polyatomic is what? -2. How many of those did I have? 1. So lead would be a +2 because the whole carbonate is a -2. So it's lead 2 carbonate. That's what I get for doing these late at night. I make too many mistakes, don't I? Alright, so it's lead 2. See where I messed up on that? It was 1 carbonate at a -2 charge. Okay, the others I got though. Alright, so that's the end of 4.4. Thanks for staying with me. I know I've made some mistakes because I'm doing this way too late at night, but sorry about that. Anyway, next will be section 4.5.